Greetings and welcome to the O-Level Revision series. In this video, we'll be starting off the A-Math chapter on logarithms, and we'll be starting with an introduction to its definitions. There are two success criteria for this video. At the end of this, I hope you'll be able to 1. Convert an equation from index form to logarithm form as well as vice versa, and 2. To evaluate simple logarithms. Let's recall the two types of functions that we've covered so far. In polynomials, we have learned about monomials in the form of ax to the power of n, where a is the coefficient, x is the variable base, and n is an exponent. Then, in exponential functions, we have functions in the form of ab to the power of x. A is still the coefficient, but you'll see that the base here is constant and the exponent is the variable. Now zooming in on exponential functions and taking a specific example, let's say I take the number 2 as the base and I raise it to an input power of 5. I'm going to get an output of 32. We get it because 2 to the power of 5 is the same as 2 times 2 times 2 times 2 times 2. 2 multiplied by itself 5 times. But let's say I want an inverse function, a way to undo the exponentiation. So this is kind of like if I add 3 and subtract 3, nothing happens. If I multiply by 2, then I divide by 2, nothing happens. So can we undo exponentiation? So is there such an inverse function? Meaning that if my input is now 32, I want to output 5. Well, the very idea of an inverse functions for exponentiation is where we get the idea of logarithms. So if I take log base 2 of an input of 32, my output is going to be 5. So like this Spider-Man meme, you can think of logarithms and exponentials as equivalent forms. Two different ways to write the same thing. Like instead of just writing y equals to x plus 2, you could make x the subject and write x equals to y minus 2. Instead of writing y equals to x times 3, you could have also said that x is equals to y divided by 3. Now, instead of writing y equals to 5 to the power of x, you can now say that x is equals to log base 5 of y. The only difference between the index form and the log form is who is the subject. Do you want x as the subject or do you want y as the subject? Moving on to exercise 1. Complete the table below. Convert these 4 equations from index form to logarithmic form. Pause the video here and give this a good try. Let's go through the answer. So instead of saying that 8 is equals to 2 to the power of 3, now we can say that 3 equals to log base 2 of 8. So another way to think of log base 2 of 8 is to think of it as 2 to the power of what gives me 8? And the answer to that question is 3. What about part B? We can write it as log base 3 of 81 gives me 4. In part C, log base 49 of 7 gives us half. And in part D, log base A of 1 gives us 0. Notice that in the index form and the logarithmic form, the base doesn't change. The base for part A is 2, for part B remains at 3, for part C the base is 49, and for part D the base is A. That doesn't change. But the subject changes. In exercise 2, we do the reverse. Complete the table below by converting these 4 equations in logarithmic form into its index form. Pause the video here and give this a good try. Let's go through the answer. So in part A, we can say that 2 to the power of 4 gives us 16. In part B, 6 to the power of 3 gives us 216. In part C, 2 to the power of negative 2 gives us 1/4. And in part D, 2 to the power of 1/3 gives us the cube root of 2. Now, before we go into computing logarithms, it's important to note that logarithms is all about that base. And let me highlight 3 special types of logarithms because of their commonly used bases. The first is binary log, and that is log base of 2. The second is the natural logarithm, and that's log base e, where e is Euler's number, which is roughly 2.71828. And this has a special notation. It is normally written as ln of n, and that's what you will see on your calculator as well. The third would be the common logarithm, and that's log base of 10. This also has a special notation. We write this as lg of n in shorthand. But if you were to look at your calculator, it's not written this way. It is written as log. So log without any base is assumed to be log base 10. So do take note of the special notations that represent special bases in logarithms. Exercise 3. Evaluate the following logarithms. Pause the video here and give this question a good try. Now, to tackle these questions, we're going to use this guide. Anytime we see log base a of b, we will ask ourselves the question, a to the power of what gives me b? So let's look at the first part, part A, log base 5 of 1. 5 to the power of what gives me 1? 5 to the power of 0 gives me 1, so the answer is 0. Part B, 3 to the power of what gives me 27? The answer is 3. 3 to the power of 3 gives me 27. Part C is a little bit harder. 8 to the power of what gives me 2? Well, the cube root of 8 gives me 2, so 8 to the power of 1/3 gives me 2, so the answer is 1/3. In part D, it's a little bit more complicated, so perhaps we can simplify this first. We can change 125 into 5 cubed. And you can see that because we have a square root, the square root is a power half. So we have 5 to the power of 3 over 2 in the denominator. We can raise it up to the numerator using the reciprocal law in indices. So we have log base 5 of 5 to the power of negative 3 over 2. So we ask ourselves the question, 5 to the power of what gives me 5 to the power of negative 3 over 2? And that is just a redundant question. The answer is obviously negative 3 over 2. Now, last one, LG of 0.01. So LG is the common logarithm. So we are talking about log base 10, and 0.01 is just 1 over 100. So we can simplify this. We can change 1 over 100 to 10 to the power of negative 2. So 10 to the power of what gives me 10 to the power of negative 2? The answer is negative 2. And that's our answers for exercise 3. Now, when evaluating logarithms, there are 5 important things that we need to stay clear of. So these are the 5 warnings. The first warning is when we evaluate log base 1 of 1. You might think that this is possible since 1 to the power of 5 gives me 1. 1 to the power of 1 also gives me 1. 1 to the power of pi also gives me 1. So this is indeterminate. We can't evaluate this. We could also say it's undefined in the general case of when base is equals to 1, because let's say I want to take log base 1 of 10. 1 to the power of what gives me 10? Because of all this, we won't allow the base to be equals to 1 when we are doing logarithms. The similar case is we won't allow the base to be 0 either. You can say that 0 to the power of 5 gives me 0, but 0 to the power of what gives you 5? So in general, we won't allow the 0 to be the base as well. The third case is we are not going to allow for negative bases. This will be set as undefined for now. We won't let the base be less than 0. The third case is we can't take log of 0. Like 6 to the power of what gives me 0? 6 to the power of anything should stay as a positive number. So it can't reach 0. So that's undefined. We can't take log of 0. And the last case is, of course, we can't take log of negative numbers. 5 to the power of what gives me negative 3. For now, we'll set this as undefined. All this will be covered in greater detail when we reach complex numbers. So in summary, we have learned about the index form and how they are the same as the log form. It's just that the subject changes, but the base remains the same. An important note that we have learned is that the base cannot be 0, 1, or negative, and we cannot take log of 0 or negative numbers. It's your turn to practice. In the info section below, I've included a link to my website, and there will be an applet there that will randomly generate logarithm questions, basic ones. Try them out and check the applet for the answers to see if you've gotten them right. Now let's reflect on the success criteria that we set out at the start of the lesson. Are you now able to convert an equation from its index form to its logarithmic form, and from the logarithmic form back to its index form? Are you now able to evaluate simple logarithms using the idea of a to the power of what gives me b? We have come to the end of part 1 on the introduction to logarithms. Stay tuned to part 2 where we'll be looking at the laws of logarithm. Thank you and have a great day of learning.